cushion of safety. So we split sections of the basic skills on a couple of primary skills, and although we practiced it all together, the idea is that you guys remind those skills to each other, and after that we will be able to practice it most efficiently. So here is the schedule of what we are presenting, and the subjects are symbolically split on basic use, play with matrices, visualization, and some scripts programming. Please try to spend 4 minutes, leaving 1 minute for questions. If you're spending more time, I will try to come to the stage and kick you out of. So the main goal is to be in time, because some of you have scheduled activities after. And with this, I would like to announce the first speaker, Ceesai Mai, and let me make you a host if you're not yet. Stop sharing. Host, yes, and Lola is already a co-host. So Mai, please try to share your screen, if possible, camera, and 4 minutes are yours.
Okay.
We didn't hear you. Please make sure your microphone is enabled.
Okay, can you guys hear me?
Now we can.
Okay. Good morning, everyone.
Good morning.
Okay, so we're going over complex. Exactly is MATLAB. MATLAB is a calculator, a powerful graphing tool, a high-level programming language, including various mathematical tools. We'll be taking a glimpse of how we can use MATLAB as a calculator, complex numbers on MATLAB, functions, arguments, and graphing basic functions. Like our calculators, MATLAB uses standard computer symbols for addition, subtraction, multiplication, etc. So as the example here, say we type in 3 plus 4, it uses this asterisk as the symbol for multiplication. MATLAB uses this short form of answer, ANS, to show the result of this operation. We can also create variables by setting, say, this as, I'm gonna use this. Okay, by setting, say, this expression as being equal to X. For example, this is especially important in cases where we are dealing with large numbers and we do not want to be going back and forth, typing the whole expression over and over again. If we wish to calculate a variable, we end that with a semicolon. To show this time around, MATLAB will calculate it, but it will not show the answer out like here. And if we want to show this again, all we have to do is just type X, and then it will bring back 15. Okay. We can also compute complex numbers on MATLAB, this is represented by I or J. For example, we can type in this expression here, P equals 8 plus 11I. MATLAB shows us the real and imaginary part of this here. We can also use commands such as real P, like here, to show us the real, just the real part. Like, and then we can also use commands such as imag P to show us the imaginary part of this. And we can compute all these other components of imaginary numbers using these commands here, perhaps angle, and then the conjugate form of the original expression. Let's say we said P equals, okay, it's saying my internet is unstable, just an FYI. Let's say of this by just typing in this, and then we can also calculate the minimum by just typing in min P comma Q. An argument of a function is a value that must be provided such as pi. Like, let's say if I type in pi here, MATLAB will give me 3.1416. And then if I type in I, an imaginary unit, it will just give me that. And then if I type in J, it will give me the same, because J and I represent the same thing, etc., etc., etc. The CLC, like if you have a whole lot of things in your command window, like here, to easily clear it out, you just type in CLC. There's another way to do that. There's a drop-down arrow on the top right corner where you can just click and there's an option for you to clear. But the easiest way is to just type in CLC.
Please speed up because time is up.
Oh, okay. We can also, this is the last slide. We can also make graphs using MATLAB. I used the graph of sine X as an example. You just type in fplot in brackets, this apostrophe sine X, just type in this code, and then it will plot a graph. We can label this graph by setting the x-axis as X, the y-axis as that, and then the title as well. Thank you.
Okay, please join me in thanking my presentation. So next time you see it's possible online, but better to do in class. Yeah, we'll skip questions for the to stay in time. So next presenter is Allison Schmidt. All your slides are here by name and number. So you can either mount or just hold it. And 4 minutes are yours.
All right, so the function that I have for MATLAB is, here, let me move this out of the way here. All right, is we're taking a derivative in finite and integration by sum in MATLAB. So in MATLAB, we can use resources such as MATLAB to calculate mathematical properties as seen before. Examples that I'm going to be covering are integration, taking derivatives of certain variables. I'm sure everyone is familiar with that from calculus. So we can solve complex subjects of derivatives through matrices and simple steps. So we initially can set a variable. So if we want A to be the values from 0 to 10, we can see that those are plotted there. And then to take the derivative of this, the function that we're using is the diff, so diff. So if you calculate, if you type in that, open parentheses and A, hit equal, we're going to get the answer. And you can see there that you're going to get the derivative of this function. Pretty simple. And we can graph these functions as well. So we can see that our initial plot of A is right here. And then when we take the derivative of it, we can see that the plot is as follows. So here's a couple more examples. So we can see that our function is y up there. And we can see that the initial graph is right here. And then once we take the derivative of it, we can see that it goes to that graph down there. So we can see that using these simple commands such as plot x and y and then plot the diff of y, we can see that this is going to give us the derivative of the variables that we need in this case, and making it pretty simple. And then the second portion that we have is integration. So we can also perform integration through MATLAB using the function sum. So basically integration is taking those values, putting them into one, basically huge mathematical adding. So we can take A again, once that is 0 to 10. Now we can plot A. Well, I guess A isn't plotted here, but we can take the sum of A, which we can see is 55, and that'll do quick mathematical equations for us, and we can find those values. Here's a trickier example. We can see the line space. A lot of stuff that's a little bit confusing, and we can see that MATLAB can easily just, in half a second, take all these equations and do it for us very easily.
Okay, please join me in thanking Allison and other questions. I do have one. So in the calculus-based definitions, we typically have increment of independent variable.
Yep.
How to insert it in things that you practiced?
And like this, we use like, I don't know how to put it. We set the variables.
Yeah, for increment like dx, should you multiply or divide? In which case you should multiply by the small number, in which case to
So we're going to divide in the case of the smaller numbers.
derivative.
Yeah.
And in
Derivative.
case of integral,
Then we're going to take the sum.
multiply.
Yeah.
Sum
So multiply.
Is it clear what I'm talking about? So she showed everything correctly, but if you want to have the same answer as analytical, you need to divide by dx or multiply by dx. More questions to Allison? If no, let's thank her once again. So here is your microphone.
Yeah.
Yeah, thank you for staying in time. It's much appreciated.
Just trying to, you just have to move the screen there, trying to be able to be in percent mode. All right.
I set it to present the mode.
Yep.
There was a
It's all right there. All right. Thank you. All right. So my presentation is about vectors in MATLAB. Okay, so here are just some examples of row and column vectors. I have the R's representing the row vectors, while the C's represent the column vectors. There are multiple ways of writing them, but I usually like to just keep the row vectors with like this, where there's spaces in between the elements, whereas the column vectors, you have the semicolons. And then here's like another way to write the row vectors is like you have the column, but within the brackets, and usually 3 numbers. The first number is your starting value, the middle number is your increment, and the last number is what goes up until. So as you can see with this first one, it starts at 1, ends at 6, and goes up by 1. However, if you have your final number be out of range, then you would end up with this message, the 1 by 0 empty double row vector. So here's just some basic operations there, right? If you add 2, if you add or multiply or etc. with 2 row vectors, then you'll get another row vector. But if you try doing some math between a row vector and a column vector, then you'll most likely end up with a matrix like this. However, there's this thing called Dirac's notation, where if you multiply the row vector by the column, then you actually get a scalar number where you have, in this case, 72. Where if you compare with the first one, which is just the A1, which is just the basic multiplication operation, then you get the matrix. If you pretty much A3 is similar to A1, except that the column vector is first and the row vector is second, you still end up with a matrix. Whereas in A4 is you have similar to A2, but you have the column first, row second, but then you still end up with the matrix, even though it's the other way around, you get the scalar value. Here's just more detailed there, where usually have the bracket notation where the row vector is the broad part, whereas the column is the ket. So if you think the form word bracket, then you get the scalar value, but if you switch the syllables around, then you get the matrix. It's just a way of remembering it. And then if you try doing it with the 2 row vectors or 2 column vectors, then you'll get an error. Yep, any questions?
Great, please join me in thanking Joshua. Any questions while Adam is proceeding towards the stage? More questions about Dirac notation? If no, let's thank for the whole presentation and showing us about Dirac notation once again. Yeah, it was helpful. Adam, please take microphone and your presentation.
Okay.
So congratulations that we are all staying in time up to now, which is hard, but we'll keep trying.
Okay. So I'm going to be talking about matrices in MATLAB. So here's kind of the why of why we need to learn about these matrices. So the way in which operators act is pretty much identical to matrices if they're not matrices themselves, like the Hamiltonian. And they're in a lot of different equations naturally in quantum mechanics. Does anybody remember the name of whatever that is in the yellow box there? Anybody? Yeah, it's the time evolution operator. And it contains the Hamiltonian right here, which acts as a matrix. So why use MATLAB? Basically just makes it easier. Matrix computations can be complex by hand, especially if the matrices are very large. And also it offers a way to visualize these matrices. I have a pretty little bar chart here. That's just one way to do that. So to actually make a matrix, Josh already kind of covered this. You can use commas to commas or spaces to separate values in rows, and then semicolons are just hit return to separate values into columns. And transposing is very, very easy. So you make a matrix Z or B, and then you put a little semicolon, or I'm sorry, apostrophe right next to it, just to get the transpose of a matrix. 2x2 determinants are usually easy to do by hand. It's just that one formula right there. But higher dimension matrices get pretty messy. It's a lot better to have a computer do it for you. So you can just do det p in MATLAB to find the determinant of a matrix pretty much any size. Matrix multiplication is also very straightforward. I just multiplied Z by its transpose, and it just spits out another matrix. Inverse matrices, again, very simple. INVP is the command to do that. And to actually visualize a matrix, you can take any matrix and then just type bar 3p, and it window should appear, and that's your beautiful bar chart for your matrix. So exponentials, there are two commands for this in MATLAB. One is not useful to us. This is the exact command that's not useful to us. It's just expp. It's just e to the power of each value in the matrix. This is obviously useless. Well, it should be more obvious in this next slide. We want to take e to the power of the entire matrix. So it's expm p in brackets or parentheses. Yeah, and this should spit out the answer that we want. But as we can see in this in the Feynman equation, oof, yeah, that's covered up right now. As we can see in the Feynman equation, h, the Hamiltonian, is e to the power of the Hamiltonian, which is a matrix, which is why this is kind of useful. All right, so yeah, just to conclude, without knowing how matrix operations could be performed using MATLAB, learning how operators interact with quantum mechanics would be much more difficult. And visualizing also helps us better understand these large matrices at a glance.
Okay, please join me thanking Adam. Any quick questions about, did you saw anything you for the first time? So basically it was clear and can be repeated. Yeah, thank you. And special thanks for showing this matrix exponential, which will be a core command for the projects and like second half of semester. So do not forget about it. So next presenter is Joseph Dieter, and he continues the story about the matrices, and he will cover one operation that we have started to study, and we'll continue. Keep going. I don't want to waste time.
All right, so I have the eigenvalues and eigenvectors in MATLAB. So by definition, an eigenvalue is a scalar that's typically denoted by lambda, which is used to transform a corresponding eigenvector. And the general equation goes that for some n by n square matrix A, the eigenvalue is equivalent to the matrix. And actually, let me. The matrix A multiplied by some vector is equal to the eigenvalue times that corresponding eigenvector. And an eigenvector is a non-zero vector that cannot be changed by any linear transformation. Kind of like I said back in the equation, if A is again is an n by n matrix and lambda is an eigenvalue of A, then X is the eigenvector of A that corresponds to lambda. So some connections to physical chemistry for eigenvectors and values. In atomic orbitals, eigenvectors are typically help describe the shape of an orbital, while eigenvalues describe the energy levels. So when solving when trying to find eigenvalues and vectors, for example, I have a matrix A here. You want to take the determinant of the matrix minus lambda times the identity matrix and set that equal to 0. So you'll end up with an equation that looks like this. And then once you find the roots of that characteristic equation, in this example, we get eigenvalues to be -1 and 8, or -8. And then for eigenvectors, we use each eigenvalue to try to find a vector such that for x1 and x2, if you kind of remember how the equation was set up of ax is equal to lambda x, we can set up a system of equations and find possible solutions for the system of equations. And one possible solution is x1 is equal to 5 and x2 is equal to 1. So the eigenvector for lambda is equal to -1 is 5, 1. And then kind of same process for the second one. But we're not here to solve by hand. We're here to solve with MATLAB. MATLAB just makes life easier. Solving by hand is boring. Ew. So in MATLAB, as you can see, I have my matrix set up here, and the command for eigenvalues is just EIG and then your matrix. So here you can see it gives us our eigenvalues, and then one way to calculate your eigenvectors is by setting up a matrix VD is equal to eigen of A, and this gives us the ratio of, or the columns are the ratio of the first component of the eigenvector, as you can see here, calculated. Yep.
Okay, please join me in thanking John. Anyone found any errors who want to catch him after some inconsistencies? Did you get the same eigenvalues by hand? And
You go back the slide.
so eigenvalues seems the same, but eigenvectors. So maybe there was some typo on the transit. Did you found it yourself? For eigenvectors. Like your answer was -2 and 1, and previous one was something like 5 and 1.
Yeah.
And go forward. Here, your eigen in the V matrix, it was like 0.9 and 19.
What I was trying to say is like the ratio of the two values in each column will give you the one of the
Okay.
solutions for it. Yeah.
Okay. So in the future, you might have written it by text.
Yeah.
So that no one tries to catch you wrong. Okay. Yeah. He was successfully defending his as people do for doctoral thesis. Okay. Yeah. Thank you, John. The next presenter is Lola. And Lola, please consider to start sharing your screen, and if you have a good mood, enable camera. Test. Do you hear us?
Yeah, I hear you.
Okay, but we neither see, we see your photograph, but not your camera or slides.
Sorry, hold on. Trying to pull it up. Okay.
Okay, so we are going from matrices to visualization, and Lola is first on this path. Floor is yours.
Okay. Good morning, everyone. I will be speaking about 2D plots of 1D functions versus 3D plots of 2D functions. So we all know 2D is planar to the eyes, while 3D is three-dimensional. You can see from all sides. 1D functions requires one input to get one output. 2D functions requires two inputs to get one output. So using MATLAB to do this would be to define your variable, which is X in this context. In this case, I'm using 0.1 to 10 to define the range of my values. So I would find the derivative of X. I would define derivative of X, sorry. And then depending on what exactly I'm trying to do, I would put in the command. So in this case, I was just trying to plot the cosine and sine function. So you could just do that with plot cos X and plot sine X, since this is a 2D function. It's a 2D function by default in MATLAB. But for a 3D function of a 3D plot, sorry, of a 2D function, you would have to define your two input parameters. So here I'm using the same range of values. X goes from 0.1 to 10. And then my input values in this case would be A and B. I'm making A equal to X, making B equals to sine X, and I'm defining my output variable as A plus B, depending on what exactly you're trying to carry out. So to plot 3D functions, you would have to specify the word 3, which I have here, plot 3 ABC. And that will plot the 3-dimensional shape of this plot. Yeah, that's all. Thank you.
Okay, please join me thanking Lola. Any questions? So
that was like perfect. The captions was like perfect the whole time.
yeah, I don't know how to arrange it, but it was really great. So Lola, everyone likes how you did. Do you know? Can you teach us how to add the labels to like your X axis?
So you could just do like X label
Exactly.
in MATLAB. Yeah.
Yep. Thank you. Thank you. Okay.
Right.
Let's thank Lola once again. And
all right, I'm talking about scripts in MATLAB, load, save, run, and then some basic loops. And so loops are really, really important because they save us a lot of time when we're doing MATLAB, because they can carry out a specific function a lot of times without us having to write out a line of code every time we want something to be repeated. So creating and loading a script, we've done this a lot in the lab already. If you want to create a new script, you just come up here on the left side of the screen and click new script, or use the drop down arrow on the new tab. Or if you want to load in one, you just drop down from the open file and then select the file from your computer, or you can use the current folder sidebar and select. And then when you open it, it'll pull up in the editor tab. Running a script. So we have a script here. So to run it, you can click run or F5, but before you run it, you have to make sure to save it because it won't run unless it's saved to your computer. And after you run it, the variables and their values will be in the workspace. And then if you have any outputs from the script, they'll show up in the command window. So there are 3 different kinds of loops. And the first one is a while loop. So here's a code. We have XYZ assigned 5, 10, 15. And the while loop continues to repeat until the function that you are defining. So if while X is less than Y, it repeats that until that's false. So X is obviously less than Y because 5 and 10. And while that's true, it'll add Z and X together and then add 1 to X because you want to increase X every time. So then it'll eventually be greater or less than, it'll eventually be greater than Y then. So that just repeats until the statement's false. And then at the end, we just display Z, and then it'll pop up in the command window. If loops, there are 3 different parts of it. There's an if, an else if, and an else. So we have the same variable setup, XYZ, 5, 10, 15. And in the first one, we have if X is greater than Z, then multiply Z by 2. But since that is false, we go on to the next part. If the if statement was the only one in there, nothing would happen because the statement's false. But because we have an else if, since the first was false, it goes to else if X is greater than Y, then multiply Y by 2. But since that is false, then we go to the else statement, which else statements don't provide another condition like the if and the else ifs, but they just provide if everything above me is false, then do an action. So in this case, print the value of X is too small. And then in the command window, it prints that. And for loops, we've done a little bit in lab already. So this is a little more complicated code, but basically we have an if statement saying that if the radius of the sphere is between 100 and 500, then run the code below. But if that statement's false, then print the chosen radius is outside of the range. So just another example of an if and else statement. And then the for loop basically does an action. So in this case, this equation right below it, for every index of a matrix. So this matrix, I can't remember who, I think Allison used a line space function, but basically it just sets up 100 indexes in a matrix. And then for k equals 2 to 100, so the second position to the 100th position, use this equation and multiply each value along. So instead of having to do a specific line of code for every position in the matrix, it does it all for us in a loop. And then this is just plotting the points you get from that matrix that the for loop creates.
Okay, please join me in thanking Write. Anything he missed and you wanted to learn from him, or any details about? So crystal clear.
Or are you so good at computer programming?
I had a whole semester of MATLAB my freshman year, and at the time I thought it was horrible, but I mean, it definitely helps in here.
So now he gives something beyond the class material and complements stuff that we may use later. Let's thank Write once again. Let's fight with him and take his microphone. Okay, so we are staying on the path of programming, so iterating with data, saving, loading, and making things to operate naturally one after another.
So yeah, basically I'm just doing the saving, variables on MATLAB, writing and reading them or whatever, simple stuff. So, so say for example, you'll like name a variable X or Y, whatever, and say you want to save those variables so that you have it for next time when you're gonna need it. So in order to do that, basically you just type in save minus ASCII, and then you name the file. So I named it save file.txt or whatever, and then you name your choice of variable you want to save. So once you've done that, you will see the file pop up into your workspace or whatever. And then if you want to find the file, you can go to your documents and then wherever you saved the MATLAB or whatever folder, and then you can go and then you'll find that you have your save file, it's over here. And then you can open that file in a notepad just to double check that it's actually the numbers you wanted to save, which it is. And then, for example, say if you just wanted to make sure that that folder has loaded, you can just ask MATLAB and type in woo, and it will show you the variables you have. And that's all.
Okay, please join me. Thank you, Siobhan. And just we might have some tricky questions. So what if we close MATLAB, open it over, and then we want to have your data back into MATLAB? What should we do?
Yeah, since you already have saved your file not in the document, you just upload the document to MATLAB. You just open it.
With which command?
With open, right?
Anyone wants to help?
No. Load.
Load.
Oh, yeah.
Yeah, load in the command line or in the script. And we will use it, save and load, when we will work with data sets. More questions? If no, please join me in thanking Sibyl. And last but not least, you can. So congratulations to everyone for staying in time. And there are very few chances that Nate will take twice bigger than everyone else.
All right. My presentation is on animations in movies in MATLAB. My first couple slides just kind of describe the process of what is happening with animations. There's not really like the code of it, but you really just do it through for loops, or Write explained what for loops are. But to make an animation, you first need a data set. So you can either code in functions to get the data, or to generate the data, and then you can bring it in from an outside source. A for loop is then used to basically get Okay, you use a for loop, and you choose how many frames you want the animation to include, and you increment that many times through the loop. So I'm just going to go to my example because it'll help a lot. So here's where I'm going to get my data from. First, I created a matrix equal to t for time. And this line space makes a linear vector, and the 100 sets it to 100 parameters or 100 values. And it splits from 0 to 2 pi. It splits that 2 pi up 100 times. So figure just creates the window. In one of our labs, we used Video Writer. It's going to create the file to save the animation to. And the for loop is going to loop through the length of t, which is 100. And it's going to get the value at the loop time t from each of our functions, and it's going to plot them on the figure. And I also plot every value of t, so you can kind of see the first plot is going to be.
Ask him to keep.
Here. Yeah. So the first plot is the particle moving, and the second plot is just that line, the path it follows. This is how, these are some labels you can create. X label, Y label, Z label, we learned those already. You can make a title for it. You need to draw now at the end of every loop because MATLAB tries to take a shortcut and not use as much computational power, and it tries to wait till the end of the loop to draw everything, but then it will just draw the last frame, so you have to force it to draw. And then again from other lab, you need, this is for saving a movie. So we created the movie at the top here. We created the file to save it to. Then you get the current frame and write it to that file. Then it'll go through the loop again for the next value to create the image again, do the same thing, and keep going through. So I get the animation. Yeah, that. Okay. That's about it. And then my sources.
Okay, please join me. Thank you, Nate. Programming, presenting, and staying in time. Any questions about his presentation? Does it mean that everyone can repeat and write the same code by now? Right? Because you have covered all skills, and codes like this shouldn't be a problem, right? You can probably ask Nate to share, and then you can download and modify line by line to change things to match your needs.
In the lab we did 2 weeks ago is obviously very similar with the, except you had the pause function, and then, but it's an animation as well. It's all the same. So.
Okay, yeah, please join me thanking Nate once again. And, congratulations to everyone with completing this skill set. It was taking additional effort from all of you to learn, prepare slides, be brave to come up front and present, and be ready to answer questions if any. So this effort is rewarded in form of equivalent to 3 successful homework assignments. So you're progressing like rockets towards success in the semester, and you deserve a free weekend just to relax or do your other things. On Monday, I'll announce we will start concentrating back, and next homework will be completely based on MATLAB. So we all will follow Nate and make a movie related to particle in the box. But it's just a seed of a thought. Now just relax and forget about physical chemistry for a couple of days. Okay, Meeting is done. Everyone is welcome to disconnect and depart. I just stay here if anyone has questions, but adjourn is announced. Thank you.
Thanks.
And thanks all speakers.